Okay. A determinant is a number, and every square matrix has a determinant. Okay, so it's a number that's associated. We have a systematic way to find it. All right. But every square matrix will have a determinant. It has to be square. Henry, how would you describe a square matrix?
The rows and columns are the same.
The rows and columns are the same, or there's the same amount of rows as columns, right? Very good. All right, so I'm going to start by showing you how to find a 2 by 2. Coincidentally, you already know how to do it.
Oh, Jackson. You're close.
The determinant of this matrix with entries A, B, C, D is AD minus BC. Is that familiar?
Denominator of the fraction for
Inverses, okay? Like I said in my video last week, Chris minus cross. Okay, so up here not only is how to find a determinant, but a couple of notation pieces that I want to show you. So first of all, DET of A, that means the determinant of A. That's what it's going to look like in your calculator, and I'll show you how to do that here eventually. Okay. Second thing is this looks like absolute value symbols, right? Well, when we're talking about a matrix, those absolute value bars mean determinant. Okay? So they could write, find the determinant of A this way, or like instead of brackets, you may see the absolute value bars around your matrix, and that means, hey, this matrix, you need to find the determinant. Okay? So, as you recognize, okay, AD minus BC, Chris minus cross is exactly how we find the denominator for the inverse. Okay, so let's practice. Go ahead and write this down. Notice how instead of the brackets, this matrix has those just straight up and down bars. That means we're finding the determinant of the matrix. Kelsey, talk me through how to do this.
So you multiply 2 and 2 because they're A and B, and you get 4, and you subtract B and C multiplied together, which is
Good.
then you get
Excellent. Our determinant is 7.
It's like the first one.
Can you handle it? Nice. Okay, go ahead and write this one down and find me the determinant.
There's something special about
Okay,
0.
all right. You got 4 minus 4 equals 0?
Yes.
Okay. I'm going to give you 30 to 60 seconds. I want you to think about the formula we use to find a 2 by 2 inverse. And I want you to think about this situation right here where our determinant is 0. And I want you to discuss whether that is a problem. Okay? 1, 2, 3, go.
I like whispering. What inverse? Inverse video? Yeah. Because you multiply as a matrix, like whatever, like you change the number to whatever. There was an inverse video that I did, you change the number order. Right. So you switch the A to the Z, you make the B negative. And then oh man, it just pops up.
All right. Pod 2. What are you talking about?
It was probability.
You said that, like in the inverse equation, that there'd be a 0 in the denominator, so it'd make it an undefined fraction, and it wouldn't work out.
And that would not be okay. All right. So what Molly said is this determinant, that's what is in the denominator of our fraction for a 2 by 2 inverse. And if we divide by 0, that would be undefined. Okay? So, since this is a 0, the inverse matrix does not exist.
But it comes out with the answer.
There we an S right there. No. Exists though. It always looks funny to me. Okay.
Why is that?
Even if it's a 3 by 3 or 4 by 4 or a 10 by 10, don't worry, you are not going to find a 10 by 10 determinant. But no matter the square matrix size, if the determinant is 0, the inverse does not exist. Okay? So you will be asked in your homework to determine if an inverse exists. It's just a matter of if the determinant is 0, it does not. If the determinant is not 0, an inverse will exist. All right. Please write this problem down. I'd like you and your pod to brainstorm about how we might be able to find x. Don't do any work, but just brainstorm for me. Okay, ready, go.
You should like factor.
So they both equal
So, and then we can take x plus 4 minus 5 minus. Oh, yeah, we get the determinant. Yeah.
All right, pod 4.
Minus 14.
I rolled your number. What are you talking about?
Minus 14.
Okay, we said you could multiply Chris by cross, or Chris and subtract cross, but then you would also get a quadratic, so you could possibly have 2 determinants.
Oh, there could be 2 different answers for x. So you said Chris minus cross. So you said we need to multiply x plus 4 and x minus 5 and subtract cross multiplying 7 times negative 2. Right? That's what you said? And that should equal 0. And we have a quadratic to solve. Can we solve quadratics? Yes, yes we can. Now, quadratics need to be set equal to what? 0. It is set equal to 0, so what are we going to have to do with x plus 4 and x minus 5? We have to multiply it out. agree with my multiplication there? So what we have is x squared minus x minus 6 equals 0. Connor, what does that factor to?
That goes to x minus 3 plus 2.
So our solutions are 3 and negative 2. How did we know we needed to do Chris minus cross?
It's the matrix, that's like straight lines.
Okay,
Oh.
because our matrix was enclosed by the straight lines instead of the brackets, it meant the determinant. So this is saying the determinant equals 0. So that's how we knew to do the Chris minus cross. Okay? All right, 2 by 2 determinants. How do you feel about them? Pretty nice, okay?
Language.
3 by 3 are
Yeah.
Now, 3 by 3s are a little bit more work, but the pattern is similar, okay? And I'm going to describe to you how to do anything bigger than a 2 by 2. So that if you were to do a 4 by 4, you could do it, or 5 by 5 or 6 by 6. Not saying that we will, but you would be able to.
Does being able to find the determinant allow us to find an inverse by hand?
I'm going to have to get back to you on that. I'm not sure if I've ever found a 3 by 3 inverse by hand, so I'm going to have to look it up. But I believe it is possible. I think there's just a lot of like.
So we're not doing that though.
We are not doing that. Okay, so these are the steps for any square matrix bigger than a 2 by 2. Bigger than a 2 by 2. The first thing you're going to do is you're going to copy everything except the right column on the right side of the matrix. I'll show you what that looks like here in a bit. Okay. Then, very similarly, we did Chris minus cross. Okay. Our Chris was what we considered our, like, we went kind of down with it, right? So we're going to multiply all of our down diagonals, starting in the top left-hand corner. Then we're going to multiply all of our up diagonals, starting in the bottom left-hand corner. And then we'll take the sum of the down diagonals and subtract them from the sum of the up diagonals. Like I said, I will show you what this looks like. Go ahead and copy this down. A, B, C, D, E, F, G, H. And if we are going to find the determinant of A, we're going to copy everything except the right column on the right side of the matrix. So we're going to copy down column 1, A, D, G, and column 2, B, E, H, and then stop. We want everything except the very last column on the right side. Okay. Now, since this is a 3 by 3 matrix, we want our diagonals to have 3 numbers. If it was a 4 by 4 matrix, we would want our diagonals to have 4 numbers. Okay? So, our down diagonals. We're going to take A times E times I. We're going to take B times F times G. And we're going to take C times D times H. And we're going to add them together. Gabe, can you multiply? Do you know how to multiply? You're going to be fine. Okay. Then you're going to subtract the sum of all of our up diagonals. So what I mean by up diagonals is this. We'll do blue. G times E times C. H times F times A. I times D times B. And those numbers get added together. So we'll end up with a number, right? We have to do a little bit of work to get there. This is not something you want to do in your head. Okay? Now, you don't have to write, if this is 1, 2, 3, you don't have to write 1 times 2 times 3. You can write a 6, right? We can multiply in our head, but you don't want to try to keep track of all of those products in your head. Okay? Questions? And let's do this. Write down this problem, please. Make it a little bit bigger there for you. Okay, we need to copy how many columns? 2, 3, 3, -1, 4, 5, 4. Okay, so our down diagonals are first. What is 3 times 5 times 1? Plus 4 times 0 times -1. Plus -2 times 3 times 4. Okay, we grouped all of the down diagonals together, minus our up diagonals. -1 times 5 times -2. Plus 4 times 0 times 3. It's nice to have that 0 there, isn't it? And then 1 times 3 times 4. Okay? Notice how all of those diagonals have 3 numbers, okay? And when we couldn't get 3 numbers in a diagonal, that's where we knew when to stop. Okay? So what is 15 plus -24? Minus 22? -31 is our determinant. Before lunch, I think I have time to teach you how to use your calculator. Do you have it out? All right, so we all know how to put a matrix in our calculator, correct? Let's go ahead and do that. I'm going to put mine in matrix A. You can put yours with wherever. Who needs more time typing theirs in? We don't have it? Okay, so quit. Quit back to the home screen. Anytime you want to do an operation with a matrix, we need to go back to the matrix menu. Under math, what's the very first thing that you see? DET, determinant. So we want the determinant, and then you can call up matrix A. Look at that, we got negative 31. Everyone get that? If you did not get that answer, you may have put an entry in incorrectly. So this is what I'm going to do. We don't have enough time to do another example, okay? So what I'm going to have happen is we're going to go to lunch. When you come back from lunch, there will be a 3x3 determinant on the board, okay? So we're going to work through that 3x3 determinant by hand and then check it with our calculator, okay? You may go to lunch.
Because lunch is